You may say to yourself at some point in this video, wow, Mrs. Curtin, this video is way better than the last one. Yes, currently I have my camera stacked on top of some yoga blocks, and I have some better lighting. So here you go. Much better video for you. Today we are going to be multiplying and dividing big, complicated looking fractions. But really it won't be so complicated because lots of things are going to cancel and it's going to be very satisfying. So anyway, if we have x over y divided by a over b, so two fractions divided. If you recall from way long ago, when we have divided a fraction, we actually change that sign to a multiplication sign and flip the second fraction. Okay, so it would actually be times b over a instead of divided by a over b. Okay, so very simple principle that we're going to be applying in a lot of different ways. So first we would have 22z to the fourth power over 15 divided by 11z over negative 5. Okay, so obviously we know we should flip this fraction, right? Because there's a division sign there. So I'm going to flip the fraction after the division sign. So I end up with times negative 5 over 11z. Then I realized that there's lots of handy things I can cancel here. I can cancel out a z, so I'm left with z cubed. I can cancel out 22 and 11, so I'm left with 2 on the top, and then 15 and 5 also cancel to be left with 3 on the bottom and negative 1 on the top. And then finally, my solution is negative 2z cubed over 3. Excellent. We're going to move on to another example. If I have t minus 2 over t plus 3, and then this is going to be just multiplied, we're not going to do a division with this one, but it's multiplied by some, complicated looking polynomial on the top and another complicated polynomial on the bottom. Well, usually when you see complicated polynomials, you probably want to factor them. So that's what we're going to do here. We get t minus 2 times t plus 3, and then on the top we'll factor that into t minus 1 t plus 3, right? And then the bottom will be t minus 2 t plus 1. So I realize that I can cancel the t plus 3's, which is nice. I can also cancel the t minus 2's, and I'm left with a satisfying, much more simple, term of t minus 1 over t plus 1. Okay, so now we're going to get into some kind of very, let's see, how do I describe it? Painstaking? Torturous? I'm not really sure. Anyway, you guys may all hate me by the end of this homework, but it's okay because you know what? You're going to be so good at factoring, and without factoring, we're really just going to drown in math. So bear with me. This chapter is not very much fun, but it does give you some nice tools. So I'm going to factor each of these terms here. So 3x squared minus 8x plus 4. I've used the x method for this. You can pause the video and kind of go through that process slowly if you'd like. But I'm going to show them all kind of quickly. And then the bottom there of that first fraction factors as the difference of squares. Okay, so just 3x minus 2, 3x plus 2. Now I'm going to multiply this by the second fraction flipped, right? But in the same step, I'm also going to just factor it. So if I multiply those two, I get 9x squared times negative 2, which is negative 18x squared. I drag down that negative 3x, so I get negative 6x and 3x. Those are the two terms that will multiply to negative 18, add to negative 3. And then I use my box method to factor out a 3x minus 2 and a 3x plus 1. Okay, again, pause the video if you want to do that more slowly. Okay, so then I'm going to take the next thing that's on the bottom. So remember I just factored the 9x polynomial, but it was on the bottom and I'm moving it to the top because of that division sign. I am multiplying and then flipping it, right? Okay, so if I factor the next one, I'm doing this very quickly again. If you practice this a million times, you're going to get really good at it. So I know that it seems painful to do it now, but practice it a bunch of times and then eventually you'll be a master. Okay, so then that's going to be x minus 2, 3x plus 1. I cancel out those 3x plus 1s. I cancel out the x minus 2s. And then I'm just left with 3x minus 2 over 3x plus 2. Very satisfying, simple ending. Okay, if it doesn't seem like there's very much satisfaction going on, you may be doing something wrong. So I would maybe go back and see if maybe you didn't flip a fraction or something like that. Like if nothing's canceling, there's probably a problem. Okay, I'm going to factor this big complicating looking thing. So I'm just factoring the first thing. And notice that I'm going to have an r and an s in each thing. And then it just factors as a normal polynomial. So nothing very complicated. The second term in the middle has a -1 exponent. So that flips that to the bottom. Okay, and then this one is a division sign. So I'm going to flip the whole thing and multiply. So I'm bringing the r plus s to the bottom. And then the other polynomial to the top and factoring those. And then I'm just going to cancel everything that I can. Again, I'm not going to show that all the way through. I think you guys are going to be fine. So this is all equal to 1 because everything cancels. So this is very happy. And I tried to draw a nice looking happy face, but it just got creepier and creepier. So I'm just going to scribble that out and pretend that never happened. Have a great day.